Welcome to page 2. I've gotten started, and this one seems a little easier than the last one we did. So you might rush ahead of me and check your answer. But this is the vector equation of a line. It gives me a starting point. It gives me two direction vectors and asks me to change it to the Cartesian form. The Cartesian form, I need the normal, and I know the normal is going to be perpendicular to the two direction vectors, so I cross them. And I get 0 minus 6. I get negative 2 minus 4. I get 3 minus 0. And I get negative 6, 3. Now, because I'm doing more math with this, I'm asking myself, can I reduce it? And the answer is yes, I can. Because if the vector negative 6, 3 is perpendicular to the plane, then a shorter version of the same thing is also perpendicular, and the opposite is also perpendicular. And I'm using it for the direction, not for the size. So I'm going to say the normal to this plane is 2, 2, negative 1, and that gives me a coefficient of x and y and z. And now I find the d value by plugging in the starting point. That's 1, that's 2, that's negative 1. 2 plus 4 is 6, plus 1 is 7. D is negative 7. And the equation of this plane is 2x plus 2y minus z minus 7 equals 0. Notice if I had used the original, if I had used negative 6, and 3 as the normal, then I would have gotten plus 21 here, because this equation would be multiplied by negative 3. It would be the same equation, or the same ratio all the way through, but a different multiple. So the scalar equation is nice because there's really kind of just one version. I mean, I guess there's an infinite number of versions, but there's one in lowest terms, or maybe two if you multiply it by negative 1. All the versions, all the answers to this are going to be multiples of each other. That's not true for the vector equation, because we know you can find any point, and there's a whole circle of directions that work. So you can take this point and go that way, or you can take this point over here and go that way, and you could define this page with an infinite number of starting points and an infinite number of direction vectors. But the scalar equation, there's only one. So when it says take this equation and turn it into a vector equation, there are an infinite number. And if you're doing this question for marks, you better show your work, because your answer is not going to match mine. The easy way to do this question is let's find 3 points on that plane, and then it's the same as question 3 that we already did. How many points are on that plane? An infinite number. So I'm going to say point A, let y equals 0, z equals 0. And I get x minus 0 plus 0 minus 6 equals 0. Answer, x equals 6. That point is 6, 0, 0. Call that point A. It's the x-intercept of this plane. I need 2 more. Let x equal 0, z equals 0. That gives me negative 2y minus 6 equals 0, y equals negative 3. That gives me point B, 0, negative 3, 0. Now I need a third point. Now be careful. The only thing you have to be careful of is that you don't pick 3 points in a straight line, because if you do, your direction vectors are going to be parallel and you don't get a plane. So do your best to pick another point that is not in a straight line. Maybe you want to pick something random. Maybe you want to choose z equals 6, x equals, and I'm not going to choose 6 because I already have a point with 0, 0, so 6, 6. So maybe I'll choose y equals 3. That feels saucy. I can choose anything I want, but I don't want fractions. x minus 2 times 3 plus 5 times 6 minus 6 equals 0. X minus 6 minus plus, I think I get plus 18. I think I get x equals negative 18. For point C. I cannot reduce point C because it's a point. Reducing it moves the point. What do I need for the vector equation? I need a starting point. I'll choose point A. I need a direction vector. I'll choose AB, which is B minus A. So that's negative 6, negative 3, 0. And this one I can reduce because I'm using it for the direction, not the size. So any multiple will work. And B, this is going to be AC, which is C minus A. Negative 18 take away 6 is negative 24. 6 take away 0. 3 take away 0. And I could use that vector, or I could divide it by 3. The vector equation of this plane is starting point plus multiples of the first direction vector plus multiples of the second direction vector. The parametric equation goes x, y, z. X is 6 plus 2t minus 8u. Y is 0 plus t plus 2u. And z is 0 plus 0 plus u.